Hi, welcome to the Physionic podcast. My name is Nicholas Verhoeven. I'm a PhD student in molecular medicine. I hold my master's in exercise physiology, and I have some undergrad training in nutrition science. Today, we're going to be discussing the molecule or the supplement creatine, and not really in a conventional sense either. We're going to be discussing it in three different areas. So, one is muscle, which is more conventional. Then, we're going to be discussing how it affects the brain, and we're going to be talking a little bit on how it affects inflammation as well. So, in those three different areas, how creatine supplementation can be beneficial. But before I go into that, I'd like to actually, for the first time ever, plug something that is my first paid ventures, my first paid product. I've been releasing free content on Physionic every week for the last 6.5 years, and I finally plucked up the courage to actually create a book. And so that's what I spent a lot of 2020 working on, is this book that's called Understanding Creatine. So the Understanding Creatine book is one that I finally have finished. Everything is completely done, and now it's for sale. So you can check that out on the website, which is actually also an announcement. I have a brand new website that I have created from scratch. So I had a lot of complaints about the old website, which I certainly understand. It was pretty crappy, but unfortunately, I have basically no budget, so I have to take on all these projects myself, and as such, it takes a long time. So I've been working on this new website, and I've been working on this book, as well as a course that goes along with the book. So if you're interested in learning some extreme details on creatine, I talk about some things that people don't talk about when it comes to supplementation. I talk about, I have a specific chapter for women and some differences, some benefits that are specific to women. I talk about hair loss. I talk about weight gain. I talk about the correct supplementation. I talk about all kinds of different things. Obviously, I talk about muscle, brain, inflammation, different diseases. I talk about aging. I talk about all kinds of different things. That's essentially the point. So the book is pretty short. It's only about 80 pages, but it is sourced with over 100 studies. I try to make each sentence pack a punch because I don't like it when books just drone on and on with unnecessary information. So this book should be a pretty easy read while still getting into cellular physiology, explaining even actually molecular physiology, explaining how creatine affects the body and how it affects all these different health outcomes. It also comes with diagrams, so I'm going to have actual visuals, and you'll see some of those if you're actually watching the podcast. You'll be able to see some of those diagrams that pop up on the screen. The course, just real quick, is about 2 hours long. It comes with optional quizzes. You obviously you're not required to take the quizzes. And they also have an added many different diagrams that aren't included in the book, and also some more added bonus content. So if you're interested, check out the brand new Physionic website, and I'll have a link for that. And if not, no hard feelings. There's going to be a lot of free information that's certainly going to come out on creatine as well. But certainly this is a one-stop shop for everyone that wants to learn about creatine. I'm truly incredibly proud of the work that I've put in, because although it's short, although there's brevity, it's incredibly concise, and it covers all kinds of different subjects, and it's sourced out the wazoo with studies that I've read. Okay, with that said, with that out of the way, let's go ahead and jump into a bit of an introduction on creatine, and then I'm going to go into muscle, brain, and inflammation, just small snippets in those categories. So creatine is a molecule that's created by the body, and so we synthesize it. People are often consider creatine a steroid, but by definition, it is not a steroid. Steroids are essentially hormones, and creatine is not. Creatine is a molecule that's synthesized by the production or the use of 3 different amino acids. Those amino acids are part of proteins. So the protein that you consume in a burger, or the protein you might consume in chickpeas, or whatever it might be. If you see protein on the label, that's made up of amino acids. So it's as quote unquote natural as you can get. But you have these two organs that actually produce creatine. So the first kind of precursor molecule to creatine is produced in the kidney, and these organs use methionine, arginine, and glycine. Those are the three amino acids, and they stitch them together. The kidney stitches together two of these amino acids, or one of these amino acids, and then allows for the production of a precursor molecule. Then that gets pumped into the bloodstream, that ends up at the liver, and then the liver finishes off the job stitching together the other amino acids to create creatine, and then it pumps that out into the bloodstream again. Typically, supplementation comes down to, well, the typical recommendation is 5 grams a day, and for most people that's enough. I don't want to make this too much about the book, but admittedly, there are caveats to that. And although you hear often enough 5 grams a day just for the rest of your life, and that, that's good enough, there are certain instances where you may not want to consume 5 grams. Some people, it may be a waste. And for some instances, it's just not enough. You need to consume considerably more. But overall, for the general population, 5 grams is recommended, especially if you take a more muscle-centric route or muscle-centric understanding of creatine. You want to improve your musculature specifically. So creatine, though, has many benefits, 3 of which I've already alluded to are muscle, in brain, and on inflammation. And in muscle, while a lot of people focus on the energetic potential of creatine, they talk about how creatine increases the cellular energy, the energy state within the cells, and that is true. That's probably its primary function. It actually has other functions as well that are muscle specific, and it has many other functions in other organ systems as well. But one of the ones that I wanted to focus on in this podcast was that it increases IGF production. And this is actually something that I've created free content on before for Physionic. I'll probably try and link that in the notes so that you can go through that yourself, but in more specificity. But it increases IGF. IGF is insulin-like growth factor, and that is essentially a cytokine or a molecule that can lead to the greater increase in muscle growth. Now, it does that through a variety of different mechanisms. So you have a muscle cell, and when IGF levels increase, that can get secreted. And when it gets secreted, it can bind to the IGF receptor. It can also bind the insulin receptor, but typically it binds the IGF receptor. And then you see a bunch of downstream effects, a bunch of signaling molecules affect each other, and eventually it lands to this effect on a particular protein within the muscle cell known as AKT. It's also known as protein kinase B, but we will talk about it as AKT because that's the most common form or common name for it. So AKT then has more signaling effects, meaning that it affects other proteins within the cell that have specific functions, but it ultimately leads to an increase in protein synthesis, right? So increase in protein synthesis, meaning that you have increases in protein production, and it decreases protein degradation. So it reduces the breakdown of proteins. And obviously, if you're trying to build muscle, that makes a lot of sense. You would want to have greater increases in protein synthesis and generally diminishment in degradation. That's not always the case, but for the most part, that is the case. So IGF does exactly that. And creatine, although the mechanism isn't completely known, creatine does seem to increase IGF levels. Now, some of the speculations as to how it increases IGF are greater stretch on the muscle cell itself. So if the muscle cell bows outwards because you have more creatine molecules ending up in the musculature, then you have more of that growth signaling that's coming from this stretch on the muscle cell itself, on the membrane itself, the sarcolemma, if you will, as well as potentially by increases in stimulation through exercise. Now, the reason why I'm mentioning that is because, well, one of the canonical ways of looking at creatine is looking at its energetic potential, which I mentioned earlier. But through that energetic potential, we get to exercise more, we get to work out more, and in more ways than a lot of people like to mention. But ultimately, if you get to do more repetitions or do more sets of exercise, then that means you have more stimulation on the musculature. You have more volume, you have more stimulation, therefore you would have a greater potential for muscle growth. So those are two of the ways that scientists have eventually come to this conclusion that creatine increases IGF. Now, there are others as well, but those are two of the primary ways that that muscle sees this increase in IGF, therefore stimulating AKT and therefore increasing protein synthesis and decreasing degradation. More protein production, a bigger muscle. Now, the other one is in the brain. So creatine also does have an effect on the brain. And while supplementation can be pretty unique for the brain, and there's some nuance there that still needs to be kind of figured out in the literature, the brain, how it affects the brain is kind of big picture is through increasing the ability to perform strenuous cognitive tasks. So in situations where people need to remember things really quickly, or they need to be able to recall things that are really difficult, or they need to be able to problem solve, it seems that creatine supplementation does seem to have a benefit in those situations. However, and I'd like to point this out, that is not necessarily the case when you're talking about just kind of a standard thought process. If you're just kind of thinking about things kind of lackadaisically, then creatine does not seem to provide any sort of benefit. So it's really in those extreme situations. If you're trying to figure out a math problem, if you're trying to figure out a problem, I don't know, let's say you're fixing a car and you don't know what's wrong with it. You're trying to postulate what might be wrong with it, like trying to problem solve your way through things, or trying to figure out, I don't know, a really complex maze or puzzle or something along those lines. So we're not talking about like, where you left your keys or something along those lines. It's not potent in those ways, but it is potent in really taxing mental games and mental things that we always go through, or hopefully we go through. So in that way, creatine does have an effect on the brain, and it has other effects on the brain as well. But I really wanted to point out this cognitive effect because I think, for me at least, this is the most interesting of the effects on the brain. However, that said, creatine doesn't always have a positive effect on the brain. Largely it does, but not always. So it's something to keep in mind. But as we get more and more literature on creatine, and there's already a ton of it out there, I think that we'll start to focus creatine on not just muscle, because that's what so many people focus on, is its muscle-centric perspective, but we can start focusing on its effect on the brain, which I think is probably the second most potent way that creatine can be beneficial. Okay, and then inflammation. I really did want to discuss inflammation as well because, it's something that a lot of people are so focused on, reducing inflammation. And I have content on that as well. And in certain instances, that makes complete sense. You do want to reduce inflammation. Inflammation is, real briefly, is just kind of the recruitment of pro-inflammatory cells, meaning like activated macrophages, activated immune cells, essentially. So kind of more generally speaking, when you can have immune cells and they can be in an anti-inflammatory state and they can be in a pro-inflammatory state, and usually they kind of fall within a spectrum. But when we have high levels of inflammation, or kind of unnecessary inflammation, that means typically you have this encroachment of all these different immune cells that are moving to a particular area. Let's say you cut yourself, right? That puffiness is because you have immune cells that are infiltrating into that area, and they're starting to secrete all these different factors. And these factors are called chemokines. the chemokines then recruit more immune cells. So it's kind of a self-fulfilling prophecy that it continues to just recruit immune cells until they deal with whatever damage is there, and platelets kind of stuff up the site and then fix it and all that stuff. So that's kind of a really basic understanding of kind of how inflammation can work, and that's a normal, necessary process. However, obviously, you can have also chronic inflammation where, let's say, you have hypertension and you have this constant goings on of inflammation that can be detrimental. So it seems like creatine there's some incredibly preliminary research that does show that creatine could have an effect at modulating that inflammatory response. So that recruitment of these immune cells. And how it does that is a really interesting mechanism, or what's believed to be the mechanism, is by increasing the release of ATP. Now, you may have heard me mention ATP in the past, and so let's take it in the context of, let's say, blood pressure or cardiovascular disease in general. Chronic inflammation, you have a lot of immune cells that are kind of floating around in the bloodstream, and they're wreaking havoc because they continuously are activated and attacking all these different things, which ends up causing all sorts of different issues that I won't go into. But the lining of your blood vessels is aligned with what are known as endothelial cells. These endothelial cells are partially responsible for the dilation or the increasing in size of the vessel, or the decreasing in size of the vessel. So vasoconstriction being the decreasing in size, and dilation being the increasing in size. So if these endothelial cells are increasing the size of the vessel, then you typically have a fall in blood pressure. And if they constrict, that means that in that local region, they're starting to increase the blood pressure. And that is all incredibly vital for our functioning. We have to have all of that going on. Now, when you have so many different immune cells that are in the bloodstream, the current understanding is that they can infiltrate into those endothelial cells and cause a lot of damage. Again, I'm not going to go into the specifics of that, but there's a lot of research that talks about this encroachment of these immune cells into the endothelial layer, and thereby creating these it starts to produce this cardiovascular disease. So obviously it would make sense to be able to kind of repel these immune cells, to tell them, hey, go away. We don't need you. We're good. And how it does that, long story short, how it does that is by a process known as exocytosis of ATP. So what it does, these endothelial cells, is they release ATP into the bloodstream. And when they do that, or the surrounding area as well, and when they do that, that actually tells these immune cells to go away, to vacate the area. So they get repelled by the ATP. And that is specific to that particular condition, to that controlled release of ATP. Now, how does creatine play a factor in this? Well, creatine plays a factor in this by essentially increasing the available ATP, increasing, again, the cellular energy state of the cell. So that is not just in muscle, that is actually also true for so many other cells. That's true in our kidneys, that's true in our sperm cells, that's true in our muscle cells, in our brain cells. So many different cells get a benefit from creatine. So in this way, it modulates this inflammatory response by allowing more ATP present for it to be released, and then for it to modulate to either act as a chemoattractant, allowing more immune cells to that region, or as a repellent by pushing the immune cells, or kind of telling them, hey, go away. So there's a lot more research that needs to be done on that, specifically in humans, but what research has been done has shown that there is an effect of creatine on inflammation in that regard, as well as in other ways as well, but that's the one that I really wanted to point out. So really, in conclusion, kind of the big takeaways is that creatine has many benefits, of which the three outlined, of course, are kind of the big three, but there's others as well. Maybe I wouldn't even call them the big three. The first two are definitely pretty pronounced, but the third one is kind of still needs a lot of research behind it. And even the brain-centric ones need a lot more research behind them. But ultimately, the point is that creatine has so many positive effects when it comes to a series of different tissues within our body. So the ones that are outlined here are like increases in muscle growth through mechanisms like increased IGF, brain function during strenuous critical thinking, and playing a role in modulating that inflammatory response that I was just talking about. So if you'd like to learn more that I haven't covered, again, I've just released my first ebook, and the course is also available, but certainly check out either one of those or both of them. If you buy the course, of course, you get the ebook as well. So it's something to consider. I go into a lot more detail, kind of the cellular functions of creatine. Again, the molecular functions. I go into supplementation. I go into digestion. I go into absorption. Really, if you want to know essentially everything that there is to know about creatine, then check it out. And you can also, if you purchase, especially the course, then you can email me with questions and things that I hadn't considered. So those are things that I can look into, and I can update the course, of which all of those updates will be free for you, as well as for the book as I release other versions of the book as well. Okay, well, that's what I've got for you. And with that, I really appreciate you stopping by. And if you can't afford the book, or you don't want to spend any money on it, I certainly understand. Again, I release a lot of content for free, so maybe not all of it, but a lot of this information can be found on Physionic just in general. So you'll be able to find it if you just kind of scour through the material that I've released over the last 6.5 years. Okay, well, with that said, again, I really appreciate it, and I appreciate you stopping by, and I hope to have the absolute pleasure, as always, to speak with you in the next one. Have a good one, guys. See ya.